Hello students, I am Mousumi Moitra from Techno India Group Public School, Shiliguri. Today I am here to discuss Mathematics of Class 12, Chapter 5, that is Continuity and Differentiability. As all you know that continuity and differentiability, that is this is a part of calculus. Here from this chapter almost 7 to 8 marks is coming, more than that also is coming from this chapter. So first part of this chapter is continuity that today I will discuss. So let us see here what is continuity that I am going to discuss now. Continuity of a function at a point. Geometrically we say that a function y is equal to fx is continuous at x is equal to a if the graph of the function is continuous at that point. So continuous means always we know that a function should be continuous, means without lifting the pen. If we can draw the function, then we can say that this is a continuous function. So continuous function means there should be some conditions, that is if a exists, that means if a is finite, definite and real number. Then if limit extends to a fx exists, then limit extends to a fx and if a, the functional value at that point x equal to a, that should be equal. These three conditions should be followed to get a function continuous. So here continuity means a graph without break. Next is continuity of a function. Some conditions it is given here, that is the function is defined at x equal to a, that is if a is a real number, then left hand limit and right hand limit should exist, and also left hand limit and right hand limit should be equal. And the third point is limit of a function as x approaches to a is equal to the functional value at x equal to a. That means fx is continuous at x equal to a if and only if limit extends to a plus fx, that is right hand limit of fx, is equal to limit extends to a minus fx, that is left hand limit of fx, and the functional value at x equal to a, that is fa. All these three are equal. So vice versa, if all these three are equal, then we can say function is fx is continuous, or if fx is continuous, then we can use these three, that is left hand limit, right hand limit, and the functional value at that point are equal. Now discontinuity of a function, few conditions here. Reason of discontinuity of a function: limit extends to a fx does not exist. So first thing is x tends to a, fx does not exist. Second is fx is not defined at x equal to b, that means fb is not defined. Number 3 is limit extends to 0, fx it exists, also fc exists, but they are not equal. So three cases, any one if it is happening, then we can say the function is discontinuous. That means either left hand limit and right hand limit not equal at that point x equal to a. Second case is suppose they are equal, left hand limit and right hand limit equal at the point x equal to b, but if b is not defined. And the third case it can be, suppose left hand limit, right hand limit both defined at x equal to c, then fc is also defined, but they are not equal. This any three cases if happens, if it happens, then we can say the function is not continuous or discontinuous at that point. Now continuity in an open interval. So a function is said to be continuous in open interval a b if the function is continuous at each and every point in the interval, not at the end points but in the interval. And continuity at enclosed interval ab, what is the meaning of that? The function should be continuous in open interval ab. Then the left hand limit is should be continuous at x equal to b point, a point. Also right hand limit should be equal at x equal to b point. So left hand limit at x equal to a point, right hand limit at x equal to b point, all should exist. Now few algebraic properties of these two continuous functions. Suppose f and g are two real functions which are continuous at a real number c. So we can say f plus g is continuous, then f minus g is continuous, f into g is continuous, and f by g is continuous. But in the last part, g at the functional value of g at the point c, it should not be equal to 0. So few important parts to remember, that is a polynomial function is continuous everywhere. Next is sin x, cos x, modulus x is continuous. Then tan x is continuous except the odd multiple of pi by 2. As we know, tan pi by 2 is infinity. Next is log x is also continuous in the interval 0 to infinity. So now let us start solving few sums. So the first problem is the function defined by fx is equal to, first function is x where x less than equal to 1, and the second function is 5 where x greater than 1, continuous at x equal to 1? That we have to find out. So continuity means, just now I have told you in definitions, that is that three conditions should follow. That means the left hand limit, right hand limit, and functional value. That three things we have to check, they are equal or not. So here first thing is at x equal to 1, limit extends to 1 minus fx. So limit extends to 1 minus fx means this is left hand limit at the point x equal to 1. So you have to check first the function which one is given, defined function where x is less than 1. So first function which one is given, fx equal to x, for x less than equal to 1, that one we have to consider. So limit extends to 1 minus fx, left hand limit, is equal to limit extends to 1 minus, in place of fx we can put x, the function, first function we can consider, and the value of 1 we have to put here in place of x, so is equal to 1. Next, right hand limit where x is more than 1, the functional value fx is equal to 5, that is a constant function. So here we have to put limit extends to 1 plus fx is 5 there, so this answer is also 5, constant function. Here we can see clearly that left hand limit and right hand limit are not equal, so we can say that limit fx is not continuous at x is equal to 1. Second sum, this type of sums are also important. In board it is coming with 4 marks questions. See, find all points of discontinuity of the function f such that f is defined as fx is equal to modulus x plus 3, then minus 2x, 6x plus 2. Three functions are given, and the this conditions are also that x is less than equal to minus 3, second case is minus 3 less than x less than 3, and the third case is x greater than equal to 3. So we have to check it here. First the function, we know that I have given here also, that is modulus function. The property of modulus function, what is? Modulus x is equal to x if x is more than equal to 0, or if modulus x is equal to minus x if x is less than 0. So obviously this is a trick here, that is means you can be confused, but no need to be confused, because x is less than equal to minus 3 means obviously x is less than 0 we can consider. So here direct we can use fx is equal to minus x, fx is equal to minus x plus 3, in place of modulus x fx is equal to minus x plus 3. So we will consider now this function. So here fx is equal to minus x. Now at 2 points we have to check the continuity or discontinuity, at x equal to minus 3 and x equal to plus 3. So for x equal to minus 3, left hand limit, we have to use the function minus x plus 3. So in place of minus x, in place of x, we have to put minus 3. So minus of minus 3 means plus 3 plus 3 plus another 3, that is equal to 6. And right hand limit, that is x equal to 3 plus fx, that is equal to which function? Now we have to consider second one, where x is more than minus 3, that function, that is minus 2x, that one we have to consider here. So this is minus 2 into minus 3, that is plus 6. And f of minus 3, that is the first function you have to consider, that is minus x plus 3. In place of minus x, we have to put minus 3. So same answer is plus 6 coming. So from these three lines we can see that left hand limit at x equal to minus 3, right hand limit at x equal to minus 3, and f of minus 3, all the three values are equal. So fx is continuous at x equal to minus 3. Now we will check it for x equal to plus 3. So at x equal to 3, again just check the function little bit, that's equal to plus 3. So same way, left hand limit at x equal to plus 3, the function we have to consider that time minus 2x. So minus 2 into plus 3, that is minus 6. Then right hand limit, that is x greater than minus plus 3, that one we have to use, that is 6x plus 2, this function you have to use, that is equal to 6 into 3, 18 plus 2, that is 20. Also f3, this last function you have to consider, that is if x greater than equal to 3, we have to consider the function as 6x plus 2. So 6 into 3 plus 2, that is 18 plus 2, 20. So here we can say clearly that is left hand limit and right hand limit at x equal to 3 are not equal. So the function is discontinuous at x equal to 3. So this type of sums, if many discontinuity you have to check, then you have to go for many points. Okay. Now next sum, find the relationship between a and b so that the function f is defined by fx is equal to ax plus 1 if x is less than equal to 3 and bx plus c if x is greater than 3. It is continuous at x equal to 3. So since it is continuous, that means left hand limit, right hand limit and functional value, that all 3 points, these are equal. So for that, first you have to find out left hand limit, that is limit x tends to 3 minus fx. So first function, that is ax plus 1, we have to check a into 3, that is 3a plus 1. Then the for x tends to 3 plus fx, that is the second function bx plus 3 we have to consider, that is 3b plus 3. And f3, that is also the first function we have to consider, that is 3a plus 1. Now all the three are equal, so 3a plus 1 is equal to 3b plus 3. After calculation we can check a minus b is equal to 2 by 3. So if a function continuous given, then we can use all the three left hand limit, right hand limit and functional value are equal. Another important sum I have shown here, that is we have to find out the value of k so that the function fx is continuous at x equal to 0 and the defined function is fx equal to 1 minus cos 4x by 8x square if x not equal to 0 and is equal to k if x is equal to 0. So here functional value at x equal to 0 is k, and left hand limit, right hand limit, both are all are equal, left hand limit, right hand limit and functional value. So first left hand limit, limit x tends to 0 minus fx is equal to limit x tends to 0 minus, what I have done here, just check it. Directly also you can do, or we can put it here in place of x tends to 0. So here we have written 0 minus h. Left hand limit, so 0 minus h. For right hand limit, 0 plus h we have to put. So 0 minus h is minus h. So if x tends to 0, h is also tends to 0. So we can write here in place of x tends to 0, h tends to 0. And in place of x, we will write minus h. So 1 minus cos of 4 into minus h, that is cos minus 4h. We know that cos minus x is only cos x. So it will be 1 minus cos plus 4h only. By denominator is 8 into minus h whole square, means we know that it is plus 8h square. So now 2 and 8 we can cancel as 4h square. So after that we can write it sin 2h by 2h whole square. Now we know the limit x tends to 0, sin x by x is equal to 1. So according to that, here also sin 2h by h, 2h, it is 1, the whole square is also 1. Here this left hand limit and functional value f0 is equal to, both are equal, so k is equal to 1 we can get. So these type of sums are very important. Practice all the sums. In this video what I have given, all are important, all have come during board exam, and 4 marks questions all are. So practice all, see the definitions of continuity, differentiability, continuity and discontinuity, and all the conditions that are very important. So this much for today. Thank you very much.